Hi, in today's lecture I will be discussing the following topics. Firstly, I will discuss about optical communication and then satellite communication, and afterwards the focus will be on the microwave and wireless communication. As far as optical communication is concerned, the light acts as a carrier signal and the medium can be free space or fiber optic or a waveguide, and there are infinite uh, bandwidths due to which infinite information can be sent via light from one place to another place. If we talk about light wave communication in free space, then we have a modulator to modulate the original information. Then we have a light source which is switched on and off to send the information in the form of light. And afterwards we have the photodetector which picks the light at the receiver, converts back into an electronic signal, and then we have amplifiers in between. If we have a at the receiver side we have a photodetector, after which the signal is converted from light to electronic signal and then amplified to be sent it to the demodulator, which recovers the original information signal. This is a diagrammatic representation of a optical communication system in free space. We have, as you can see, the information source, which and then we have a modulator which modulates the information signal over a carrier signal, and the carrier signal is the light. Information is received by the modulator. It switches the light source on and off with reference to that information it is receiving, and the LED over here sends the light uh, wirelessly, and then we have a laser over here, laser wireless communication. Photodetector detects the light, converts back into an electronic signal, amplifies it, and then the demodulator recovers the original baseband information signal. We have light sources over here which can be LEDs and lasers, and they can be monochromatic in nature and the no, coherent in nature, and the laser is the most powerful light source over here, which is monochromatic in nature, and it can send the wireless uh, uh, it can send the uh, information from the transmitter to the receiver wirelessly. We have a modulator in the light source which can be an intensity modulator which varies the brightness of light with reference to the information it is receiving, or it can be a on and off modulator which can switch on and off the light according to the information, the digital information it is receiving. So we can have two kinds of modulators, the intensity modulators for the analog information, and the digital for the digital information we have the on-off modulator. In light communication or optical communication, a modulator can be a kind of this circuit where we have a transistor which is attached to a resistance and the LED, and we have the information signal which is received over here. We have the biasing voltage and the transmitter based on the information signals which is on and off the LED which sends the uh, light wave information. At the receiver circuit, we have a photodetector which converts the light from which converts the light into electronic signal, amplifies it, and then we have the demodulator which recovers the original information. We use laser for practical applications because it sends information over a long distance wirelessly, and LED cannot send information to a larger distance than laser, so laser is used for practical applications over here. So we have optical communication. We have already studied it in the wireless manner. Now we have optical communication. We can study it with a fiber optic based optical communication system. In wireless communication, we have transmitter and receiver, and in between we do not have any kind of fiber optic. While in fiber optic communication system, we have a fiber optic in between the transmitter and the receiver. Fiber optic offer a immense amount of information, and we can send thousands and millions of signal in the form of light with the fiber optic. From the transmitter we have LED and laser, and that light is being given path within the fiber optic from the transmitter to the receiver. So the information signal, which can be a voice, video and computer data signal, is converted into in the form of light, because it is the compatible medium through which the information can be sent through the fiber optics, and the information are being converted into from analog to digital pulses, and these digital pulses on off the light source, and then these light pulses which are on off are being fed into the fiber optic, which transmits that information over a long distance. At the receiver side we have a photodetector which receives the light and converts those light pulses into electronic signals, which are being amplified and reshaped, and then we have the original information which is recovered after the D to A conversion. Coming from the demodulator, we have the original digital signal, from which D to A, after D to A conversion, the original analog signal is recovered, which can be a voice or a video. This is a diagrammatic representation of our optical communication system. The information coming over here, the modulator, the A to D converter, converting information into digital. The light source is being controlled by this digital pulse. It ons and offs and sends information over the fiber optic cable, and then the light is being observed by the photodetector, converts it into electronic signal, amplifies it, and we have a filter over here to reshape the pulses and the digital pulses coming over here, and then these are being decoded to recover the original information, or we can have a D to A converter over here which converts the digital information into the analog original information. We have multiple applications of fiber optics. The most common are in telephone systems as well as in cable TVs, and it is a backbone of internet, the fiber optics. All the information of the internet, it is the fiber optic is networks are being responsible for that information interconnection between multiple regions and subcontinents. Mostly the fiber optics are used to interconnect the computers in the form of LAN, MANs or WANs. There are multiple benefits of the fiber optic cables over the conventional electrical cables. This can be because the fiber optics offer a wider bandwidth. There is low loss as the communication in the form of light, and these fiber optics are very lightweight. They are of small sizes, and there is not a problem of the security where the information is being uh, picked up in between the transmission system, and due to the light communication, the interference doesn't affect like the in electromagnetic induction, and we have safe communication in fiber optics. Now we can see the second topic, which is the satellite communication. We have to realize that satellites are not the originators of information, they are just the relay stations. The information is communicated from a station on the earth. Satellites receive that information and relay it back to the earth after the amplification of the information, and so the satellites are being said as repeaters over here. And this is the whole scenario which is explaining the same thing which I explained in the previous slide, that the information coming from the ground station of the earth satellite receives that transmitted signal, amplifies it, translates it to some other frequency, and then retransmit back it to the receiving station on the earth. The frequency at which the information is being sent from the ground station to the satellite is being termed as uplink, and the retransmission of the information after amplification in the satellite sent back to the earth to the ground station is being sent as downlink, and the device which is holding the transmitter and receiver circuit in the satellite is being termed as transponder. So diagrammatic representation over here, the earth, we have a ground station transmitting at 6 gigahertz uplink frequency the information to the satellite, which amplifies it and then retransmits it at some other frequency of 4 gigahertz, which is being termed as downlink, and the earth station receives that information. So the satellite is being acting as a repeater over here. Then we have different frequency allocations for the satellite, and the frequencies of the satellite are being divided into various bands, and we have the C band, which is the most common, and the C uplink frequencies are written over here, and the downlink frequencies are written over here. And then we have this is a table in which we have multiple bands, frequency spectrums, in which we can do the uplink and downlink satellite communication. Now we have the third topic, which is the microwave communication. Microwave communication frequencies are higher than the radio spectrum and lower than the optical spectrum, and they are in between those. They are very ultra high and super high frequencies. The microwave frequency band can be 1 to 30 gigahertz, and higher than 40 gigahertz are being termed as millimeter wave communication over here. These are the different bands of the microwave communication. You can see it over here. There are various benefits of the microwave communication, and the two most important are, the first one is the spectrum crowding. It is saying that many communication nowadays happen in the radio communication, and the bandwidth is preoccupied in radio communication, and we have in microwave communication not much bandwidths are utilized over there, so wide amount of bandwidth available in the microwave spectrum, because the higher the frequency we go, the more complex will be the implementation of the electronic circuits, which can be the modulator, multiplexer, or these kind of circuits, and the easier is the making of the circuits in the radio frequency. So not much people like to do to implement complex electronic circuits to do communication in the microwave communication. And the second advantage of that is that we have due to greater bandwidth, the amount of information sent can be at a higher rate. There are this slide is telling us about the disadvantages of microwave communication. You can see that the higher the frequency goes, the more complex will be the creation of the electronic circuit. And the second disadvantage is that we have line of sight communication between the transmitter and the receiver, and we cannot do multi-hop communication due to that. In microwave communication, we have the transmitters, receivers, and the antenna, and the same techniques with reference to modulation and multiplexing in microwave communication happen as in radio communication. The RF communication part is different. Once we see the circuit, we will have better understanding this thing over there. So the slide is telling us about the transmitter operation, which can be demonstrated in the figure over here. You can see that the information signal is AM modulated over here, and the oscillator signal generated over here, and then we have multiple stages of the frequency multipliers raising the frequency of the oscillator signal. We have a filter over here, and then this signal is mixed up with the audio signal, which was previously AM modulated over there, and then again a filter over here, and before sending it to the antenna, again there are multiple power amplification stages, after which the antenna receives that electronic signal at a high frequency and amplitude, and then converts that into the electromagnetic microwave, and this microwave is then sent in a line of sight communication way to the satellite or the near microwave link. In the previous slide, we have seen this. In this slide, we have the microwave transmitter block diagram, and in this slide, we have the microwave receiver. Uh, Again, the transmitter diagram, and the receiver diagram will be over here. So you can see over here again the same thing happening over here. This is another picture of the microwave transmitter diagram. You can see that the oscillator signal is undergoing multiple frequency multipliers to raise its frequency, and then this is mixed up with another frequency to raise its frequency, and this part is basically raising the frequency of the oscillator signal to the microwave frequency range, and then we have multiple band pass filters over here, and then we have the amplifiers in at here. Some stage we can mix up that microwave frequency carrier signal with the information signal. Here we are doing the power amplification, and then the antenna converts that electronic signal in the microwave frequency range with high power level and converts it into an electromagnetic wave which can be sent to a near microwave wave. So now we will see the receiver structure of the microwave link. This is the literature which is telling this diagram response. You can see the antenna receiving the microwave signal from electromagnetic wave. It is converted into the electronic signal, and then the whole thing over here is being responsible to lower the frequency of the microwave frequency, and then the information is received at the demodulator, which uh, recovers the original information signal over here. In microwave communication, we have the transmission lines which can be different from the traditional coaxial cable communication. As in radio frequency range, we use hardline cables over here, and these hardline communications, these hardline cables can also be replaced by the waveguides which are used to communicate the microwave electronic signal from one place to another place in a wired manner. We have antenna used in microwave communication which are smaller than the radio frequency antennas. The higher the frequency, the smaller will be the size of the antennas, and the more the complex will be the construction of the antenna in the microwave frequency. Now this is the fourth topic, which is the wireless LAN. In addition to the cell phone applications, there are many more applications of the wireless LANs, and these can be Bluetooth, Zigbee, NFC, radio frequency communication. Let's see over here. We have a LAN in which we have printers, we have computers, and we have multiple different devices of computers which are attached to each other, and their applications can be interconnected with each other. We can have LAN connection. We have a cable which is the Cat5 cable which is used to do their interconnection. We can have MAN networks, we can have WAN networks, we can have personal area network of a person with his mobile, with his iPod, or with his laptop personally interconnected with each other for multiple applications. We can have Bluetooth communications. In the Bluetooth we have a master node, and then we have slave nodes. In this way we have different systems and different devices which are connected via the wireless Bluetooth link. We have Zigbee wireless communication, and the different rates at which the Zigbee and the Bluetooth communications happen, and different ranges over there. And this is a different demonstration of the Zigbee interconnection between different systems, mobiles, and devices. We can have infrared communication like in the TV remotes, by which we can change the channel of the TV, and this is the demonstration of the circuit of the infrared wireless. We can have radio frequency wireless communication, and this is the circuit of the radio frequency wireless communication demonstration over here. Thank you very much.